Okay, so on the quiz I asked you, we have this symmetric matrix here, 3, 9, 3, sorry, that's not, I wrote it, copied it wrong. -6, 12, 12, 26. Now, the numbers were perhaps a little bit bigger than what you would be used to, but it's 2 by 2. You should be able to handle this, okay? It's a quiz and a bit for extra credit, so the extra credit was find what a cube is using this diagonalization method, not just working it out. I would not give points for that. Okay, step 1. The characteristic equation. That's perhaps where the most kind of calculation goes into. We subtract lambda from the diagonal. And so we get -6 minus lambda times 26 minus lambda minus 12 squared, which is 144. Okay, so we expand. -6 times 26 is 120, is minus 156. Then plus 6 lambda minus 26 lambda plus lambda squared minus 144. Now, if you get wrong here, then you're in trouble a bit. Okay, so this is equal to 0. So that's like terms. This is minus 20 lambda, and then we have minus 300 is 0. So we need two numbers that multiply to 300 and add up to 20. I hope it was not too hard to see. It would be 30 and 10, but now we have to think about it. So we need minus 30 and plus 10, right? To get the minus 20, add up to minus 20, and then multiply to negative 300. So this gives me lambda equals 30 and lambda equals minus 10. Okay, step 2. We need to diagonalize we need to find the eigenspaces for lambda equals 30. So we subtract 30 from the diagonal, so we get minus 36, 12, 12, and then subtracting is minus 6, right? Yeah. No, minus, what am I saying here? No, minus, wait. 30 minus 26 is minus 16, sorry. Is minus 4. Well, sorry, I'm thinking about something else. Sorry, it's minus 4. Okay, now, okay, good. So we're gonna have to introduce some fractions. We are used to that, but since it's a 2 by 2, it's really not a big deal. So we do divide by minus 36. We get 1, and then that is 1/3, right? So minus 1/3. There's a minus sign there, and then we get 12 and negative 4. But as long as the second row now becomes 0, that's why. So it's minus 12 times row 1. That's what gives 1, negative 1 over 3, and then we get 0 here. And if we multiply this with negative 12 and add up, then we get also 0 there. Okay. So this means a free variable, and we have a pivot variable and free variable. So x1, x2 is equal to itself, the free variable, and x1 is equal to 1/3 of x2. So we get x2, 1/3 and 1. We need to normalize. You can, if you want, you can instead multiply with 3 and use this one. It's sometimes a little bit easier because even if you normalize, then with fractions it gets a bit awkward. So let's do it this way. In the review I didn't do this, but it might pay off. The end result will be the same, by the way, that we've discussed this, right? There's only one normalization. Okay, so it's the square of 1 plus the square of 3, that is 9, so the square root of 10. And so our basis will be 1 over radical 10 and 3 over radical 10. Okay? Eigenspace for lambda equals negative 10. So now I'm going to add the 10 to the diagonal. Minus 6 plus 10 is 4. 12, 12, and then 16. So 12, 12, 16. Okay, in this case, we are okay. We can divide by 1/4 here. We get 1, 3, and then we have 12, 16. So if I use this pivot now, so row 2 minus 12 times row. What do I do? I did something wrong. Sorry. I said I add 10 to the diagonal and I subtracted it. I don't know. It's 36. Okay, so 36. Why do I know a mistake? Because I'm going to subtract 12 times this row and I was not going to get the 0 row. That could not be. Okay, so 1, 3. So 0 times negative 12. So that's a 0. Now we're good. Okay, this is the free variable. The pivot variable. This is the free variable. So we have x1, x2. x2 is just itself, and x1 is minus 3 times x2. So we get x2 times minus 3, 1. It looks very familiar, all right, because, yeah. So we get this guy, that's square root of 1 plus 9, again, square root of 10. And so our basis vector, the normalized orthonormal basis is minus 3 divided radical 10, 1 radical 10. Okay. So we can write down what P is. So that's step 3. P is, we put these two guys in the matrix. That is 1 radical 10, 3 radical 10, minus 3 radical 10, over radical 10, and 1 over radical 10. Okie dokie. And then what is D? Well, this guy corresponds to 30, and this guy corresponds to negative 10. So this will be my D. And then so for the extra credit now, this is all I wanted for the main question. The extra credit, I also asked you to do this. We know that, let me write down what we know. We know that P inverse A. P is the diagonal matrix, so it means that A is P, D, P inverse. But we also know that P inverse is the same as P transpose. So, sorry, yeah, I wrote it this way. P transpose. So we know that this is P, D, P transpose. And therefore A cube, that was the question, right? I forgot. Yes, A cube. A cube is P. Well, let's write down what P is. Okay, so again, I don't want to keep writing this radical 10, so I factor that out. Okay, so I'm going to write P just as 1 over radical 10. I factor out radical 10, and I have a 1, 3, negative 3, 1 left. Then I have D. Now I have to go in doing A to the cubed. That will be D cubed, right? So I have to take the cube of 30. Okay, you might want to do this with a calculator or something like that, but it is 27,000. I know it sounds big, right? 0, 0, and then minus 10 cubed is minus 1,000. And what about the transpose? Well, the transpose, of course, also has 1 over radical 10, and then we just transpose. So 1, negative 3, 3, 1. Okay, so this is just a transpose of this guy. Okay, we have also seen that is 1 radical 10 combined to 110, and we can divide here. So this and this will come divided by 10 here, and so I'm left with 1, negative 3, 3, 1, 2700, 0, 0, minus 100, and then 1, 3, minus 3, 1. Okay, so what we get, the numbers are a little bit big, but not too bad calculations. 2,700 times 1, that's 2,700. 2,700 times 3, that is 8,100. Okay, right. Then in the bottom, 0 times 1 is minus, so plus 300, and that is 0, it's minus 100. Okay, and then finally, now I have to multiply this. The first element is 2,700 minus 900, that is 1,800. The next one is 8,100 minus plus 300, so 8,400. Then we get 2,700, 8,100 plus 300 is 8,400. Okay, this is symmetric, that's already good thing, and then 3 times 81, that is 243 hundredths. Okay, it sounds a bit weird. So 243, 242 hundred. Okay, so 3 times 81 minus 100, that's that. And that was the final answer. Okay.